r del u del r plus del 2u del theta square equal to 0. Okay, that is nothing but your Laplace equation in polar form. We want to solve it. Now you see, usual method of solving this kind of equation is you write u as a function of r and then product it with another function that is a function of theta. Now r depends totally on r, and so r must be independent of theta, and theta depends totally on theta, so it must be independent of r. Then how can we write this differential equation? So we should assume u equal to this, that we can always do it. So your answer begins somewhere here, and let u equal to r into theta, where r is a function that is totally dependent on r, so independent of theta, and theta is a function totally dependent on theta, so independent of r. Then what will happen to our partial differential equation? Then we will have r square del 2 del r square. What is u now? U is r into theta. That's it. Plus again r del r of what u? What is u? U is r into theta. Plus no r here, so del 2 del theta square of your u is again r into theta equal to 0 as it is. Now you see, can we simplify it? Your theta is independent of r, so I can take it out. Let's take it out. So I am taking out theta. Here also theta is independent of r, so I can take it out theta. And then at last here r is independent of theta, so I can take it out r. Then what are we left out with then? Well, r square, we have taken out theta, so I forgot del 2 here. That is double partial derivative of r with respect to r. Then you have already taken out theta, and so you are just left out with r del r del r plus r double partial derivative of theta with respect to theta equal to 0. Now you see, r is a function of r only, and you are partially differentiating with respect to r. So you can just write it as ordinary derivative. And so theta as it is, theta as it is. Here also theta is a function of theta only, so you can just write it as ordinary derivative. Since r depends only on r, the ordinary derivative must be same as the partial derivative. Here also, since r depends only on r, the ordinary derivative must be same as partial derivative. Here theta depends only on theta. The ordinary derivative and partial derivative must be same. Okay. Now what can we do? You see that can we separate r and theta? If we can, then how? Well, if we divide by theta, then you'll have this quantity independent of theta, and if we divide by r, this quantity will be independent of r. Let's do it. So we divide above equation by r into theta. What do we get? We get r square d2r dr square plus r dr, that is derivative of capital R with respect to r and double derivative of capital R with respect to r. Let's write it to the other side. Let's put it other side, and so we are dividing by theta, double derivative of capital theta with respect to smaller theta, and then you are dividing by capital theta, so we have 1 by capital theta here. You are dividing by r, so you have 1 by r here. You are taking this quantity to the right hand side, so side change, you must have to change the sign. Let's change the sign. Okay, now if you see the left hand side, that is independent of independent of theta, whereas right hand side, if you see that, that's independent of, well, r. This quantity, the one that is written in black, that is independent of r, whereas this quantity that is written in red, that is independent of theta. Well, then what can we say? Well, it must be a quantity that is independent not just of r but also of theta, and once again that must be a quantity that is independent of r because of right hand side. That must be a quantity that is independent of theta because of left hand side. So what can we say? It must be a quantity that is independent of both r and theta. Let it be k. Let's say so. Let that quantity that is independent of r and theta be k. Well, as soon as we have it, we got two different equations now. What do we have? Okay, if you take the left hand side and you forget this, then you have r square double derivative of r, we can just double derivative of r plus r single derivative of r equal to k times r. And if you forget the r term, then we have, if you forget the r term, then you have double derivative of theta equal to minus k times theta. Well, those are ordinary derivatives, or rather these are the differential equation of, not this, the first one is a differential equation of order 2, and the second one is also, both are differential equation of order 2. Second one is also a differential equation of order 2. Now, what if k were 0? And what if k were negative? And what if k were positive?